Hello, good morning to everyone. Myself R. Vishwanath Reddy, chemistry lecturer. Today, I would like to discuss one important topic in the 12th standard. That chapter is aldehydes. In these aldehydes, the functional group is C double bond OH. The another one is called as ketones. In these ketones, the functional group is RC double bond OR. So, when we discuss this topic, we need to go sequence following like this. The first we need to discuss about the introduction. The second part we need to discuss about the nomenclature, followed by preparations. Next, chemical properties. Finally, we have to worry about the physical properties. Physical properties. So, now I want to focus one topic here, the chemical properties. Why? Because this is the topic is most important for competitive examinations. Let me start with the chemical properties of the alkenes, carbonyl compounds, that is called as aldehydes and ketones. So let me go chemical properties. Generally, aldehydes and ketones can execute the following chemical properties. In that, first chemical property is nucleophilic addition reactions. Nucleophilic addition reactions. Second chemical property is nucleophilic addition. Nucleophilic addition followed by elimination. Followed by elimination. This is also nothing but condensation reaction. Third one is called as a oxidation reactions. This is also called as test for identification of aldehydes and ketones. The next one is reduction reactions. The next one is reactions with alpha hydrogens. The next one is reactions without alpha hydrogen. Without alpha hydrogen. Alpha hydrogen. These are the main chemical properties can be executed by aldehydes and ketones. In that, let me start with first chemical property, that is called as a nucleophilic addition reactions. Let me start with first chemical property, nucleophilic addition reactions. First, you want to understand the nucleophilic addition reactions. What is meaning of nucleophile? Nucleophile is nothing but which is having excess of electrons. Is having excess of electrons. When either aldehyde or ketone is a or C double bond OH is a aldehyde, either it may be you can also take the ketone, no issue. When this pi bond is polarized towards the most electronegative atom, we'll get the partial negative charge here, partial positive charge here. Now this carbon I can call as electrophilic carbon. This we are calling as a electrophilic carbon. Electrophilic carbon. Now when nucleophile is there with you, the nucleophile is going to attack on electrophilic carbon. Then we are getting the product is like this. This is called as a nucleophilic addition reactions. Now there is a so many aldehydes and ketones are there with us in that, which is a more reactive in nucleophilic addition reactions. That is called as a reactivity order. We need to discuss about the reactivity order. Generally, this reactivity order depends upon the two factors. One factor we are calling as a electronic effects. One factor we are calling as a electronic effects. Another factor we are calling as the steric effects. How electronic effects can be decide the nucleophilic order? When electron releasing groups are increases, the reactivity towards nucleophilic addition reactions decreases. But when electron withdrawing groups is nothing but what negative I groups, it is a positive I groups. When electron withdrawing groups are increases, reactivity increases, and whatever the steric hindrance is there, steric hindrance generally steric crowding, which are inversely proportional to nucleophilic addition reactions, Due to this order, among aldehydes and ketone, which is more reactive is aliphatic aldehydes are more reactive. Then after that, aromatic aldehyde, somewhat less reactive. Aromatic aldehydes less reactive. Then aliphatic ketone. Then least reactive is aromatic ketone. For example, let me take one order, few examples. Formaldehyde HC double bond OH, acetaldehyde CH3C double bond OH. Okay, next propanaldehyde CH3 CH2 C double bond OH. Next is a benzaldehyde. This is when you take this all the things in that, which is a more reactive. See, if we come to the electronic effects, whatever the hydrogen is there, it is a not electron releasing group, it is not electron withdrawing group. And steric crowd also is very less here. Why? Because small atom. Whenever it is a small atom, steric hindrance is very less. That's why this is a more reactive in the nucleophilic addition reactions. But when you go for this molecule, it is called as a electron releasing group. When electron releasing group increases, the reactivity further decreases. That's why when compared to the formaldehyde, acetaldehyde is less reactive. And look at here, this and this, there is a two electron releasing groups are there here. That's why the reactivity further decreases. The finally, look at the benzaldehyde, it is create the so much steric crowding, so much steric hindrance. Is create the so much steric hindrance. That's why this is a very least reactive. So benzaldehyde is the least reactive in these nucleophilic addition reactions. Benzaldehyde is very least reactive. Okay, why? Because there is a more steric hindrance. Now let me take another order. In that another order, acetaldehyde CH3C double bond OH. Next CH3C double bond O CH3. Acetone Next is a CH3 C double bond O benzene acetophenone. The least one is a benzophenone. This is a benzophenone. When you take these all molecules, which is a more reactive towards the nucleophilic addition reactions, then I can say that the first is acetaldehyde. This is a more reactive, and this last one is a very least reactive. Why this is the least reactive? If you come and there is a two phenyl groups are there here, the two phenyl groups are create the more bulkiness or more steric hindrance to attack the nucleophile. If why? Because two benzene rings are there in coplanar. When both benzene rings are there in the coplanar, nucleophile attack is very difficult. Nucleophile attack will not happen. But here, look at here, there is only one electron releasing groups are there, and also due to the presence of hydrogen atom here, less steric hindrance. Less steric hindrance also is there, and only one electron releasing groups are there. That's why acetaldehyde is a more reactive in nature. So then look at in this molecule and this molecule. I already given the order that aliphatic ketones are more reactive when compared to the aromatic ketones. Again, you know that why aromatic ketones are very least reactive. This one of the benzene ring is creating the more steric hindrance to attack the nucleophile. Let me take another order. In that another order is this is a benzaldehyde. This is a benzaldehyde. Now this benzaldehyde is contains one of the electron releasing group, that is called as a NH2, and one is a electron withdrawing group, that is called as a NO2. Now next is the formaldehyde, HC double bond OH. Among the 1, comma 2, 3, 4, which is a more reactive towards the nucleophilic addition reaction, and also write the decreasing order of nucleophilic addition reaction if they ask the question. We know that formaldehyde is the most reactive in nature. Why formaldehyde is the most reactive nature in nucleophilic addition reactions? I already mentioned that these hydrogen atoms are very small in size. So next in benzaldehyde, this 1, 2, 3, these all are the benzaldehydes. In that, electron withdrawing group containing benzaldehyde is the more reactive. That's why third one. And this is the electron releasing group. NH2 is the electron releasing group. That's why the second one is come to the least one. And normal benzaldehyde is there in exactly middle between the electron withdrawing group containing benzaldehyde, electron releasing group containing benzaldehyde, in that normal benzaldehyde. Normal benzaldehyde. So the already I given order, electron withdrawing group containing benzaldehyde is a more reactive. But when compared to the other benzaldehyde, formaldehyde is a more reactive in nature. Formaldehyde is a more reactive in nature. So let me discuss one of the example of the nucleophilic addition reactions. The example of the nucleophilic addition reactions are examples of the nucleophilic addition reactions are one is addition of HCN, addition of HCN, addition of HCN. What is a HCN? HCN is called as hydrogen cyanide. Hydrogen cyanide. When aldehydes are ketones, you can add to the HCN. So suppose if you take the RC double bond OH, this is the aldehyde. For this, you can add some amount of what HCN. In the presence of base is the catalyst. The H can be break down into what H plus and Cn minus. Now H plus will go and attack on this oxygen. Why? Because this bond is polarized. Then Cn minus is come and attack. This is a nucleophile here. This is a nucleophile. Then we are getting R, C, OH and C triple bond N, and there is a H. This name we are calling as a cyanohydrin. There is so many applications of cyanohydrin. There is so many applications of cyanohydrin. What is the first application is, with this cyanohydrin is undergo hydrolysis by taking 2 moles of water molecule. Hydrolysis by taking 2 moles of water molecule. This I can call as a complete hydrolysis. When cyanohydrin is undergo complete hydrolysis, generally there is a formation of carboxylic acid. So, is the interesting thing is, whatever the C triple bond N is there, the C triple bond N is converted into carboxylic acid when you do the hydrolysis. Then we'll get the R C O H H. The C triple bond N is converted into what? COOH. Is a COOH. This is the first one we'll get it. When this is undergo partial hydrolysis, this is undergo partial hydrolysis. Partial hydrolysis is meaning of that only one water molecule it is add. Then whatever the C triple bond N is there in this cyanohydrin is converted into amide. Is converted into what? Amide, or C double bond O NH2. Suppose if we add one of the lithium aluminum hydride followed by hydrolysis, it is called as a strong reducing agent. Strong reducing agent. When you add the strong reducing agent, whatever the cyanide is there, cyanide is converted into amine, primary amine. Then we'll get the ROH, H, and CH2, NH2. It is a primary amine. And primary amine, this is a carboxylic acid. Sorry, this is a amide. Sorry for that. This is a carboxylic acid. Means cyanohydrin is undergo complete hydrolysis. Cyanohydrin is undergo complete hydrolysis. Okay, we will get that complete hydrolysis. We will get the carboxylic acid. When it is undergo partial hydrolysis, we get the amide. When it is undergo reduction by using lithium aluminum hydride, then we get the primary amine. So this is the best example of the nucleophilic addition reaction. Thank you so much. Still so many reactions are there. I want to stop my demo class here. Thank you so much.